preliminary operational data that would help us build the final project. So the answer is that we can do a lot of book studies, if you will, or actual, environmental measurement studies that could convince the FERC and other agencies that we could be successful in implementing a project that does not have an undue impact on the environment. We would put devices in the water only during the license period. If we apply for a pilot license, which is one of the three alternatives, that would be for a 5-year period. And that would essentially, and that is the license that FERC is encouraging wave energy developers to apply for right now. And that's fairly new as well. It's part of their incremental implementation strict scrutiny policy. And we find that attractive. We haven't made that decision. We probably won't for another year or so until we get some more data from these environmental studies. But we think that a pilot license is very attractive to do, which is a mini project. It can't be any larger than 5 megawatts according to the FERC requirements. We have made an application in our preliminary permit for a 40 megawatt facility. And just to put that in final perspective, 40 megawatts is actually a small power facility. A large power facility that PG&E might own and run is 1,000 megawatts. So once again, we're moving slowly, incrementally, bit by bit, build upon experience. Don't go out and build the big thing right off the bat because you'll probably get it wrong. We want to get it right little by little first.
Thank you. Mr. Gurney, are you ready to proceed? Mr. Gurney, normally we allow 3 minutes. You've gone to the trouble to present this PowerPoint presentation. Please proceed as quickly as possible, keeping the 3 minutes as much as you can, but I will stop you at no more than 10 minutes, just so you understand that. Storm on the horizon.
All right, this is going to have to do. I'm sorry for the delay.
That's right.
Is that today's weather forecast up there?
Okay, I'm not going to waste your time any further. My name is David Gurney. You already know who I am. We're here to talk about wave energy. Wave energy, in fact, is a misnomer. All energy is, in fact, waves. We're talking about ocean energy. I'm not going to go into politics here. I just want to present information for the board because it's time for us all to get up to speed about what we're actually talking about. We have just been going down this procedural road long enough. This is the Finnevera buoy. This was in Oregon, placed there in September 2007. You'll notice on the top of this thing is solar panels and windmills. Now, this is a power generating buoy. You would wonder why they wouldn't just put a reducer on it and get their power that way, but instead they have solar and wind on top of this thing. This is Finnevera's promotional video. I'm sorry, I have this moving images on the computer, but I was here earlier and we had this all hooked up, but PG&E unplugged my computer and it's not working, so I apologize for the technical difficulties. But I was going to show what these things look like on the surface and underwater through this video. Next time I'm going to have to try to not be unhooked by PG&E. This is what the fate of the Finnevera buoy, which is 72 feet high. It's now on the bottom of the ocean outside Newport, Oregon. The makers said that they would recover it, could recover it. They have not recovered it so far. It's in the middle of the crabbing grounds up there, and the crab fishermen up there are not pleased. This is one form of wave energy. This is called the oscillating water column. You'll see on the right, when the water comes up, it turns a turbine on the top of this thing. When the water comes down, it goes the other way, and that's how the power is produced. This thing is, I think, about 25 feet above the water. Those pillars don't actually touch the bottom. They're just under the surface about 10 or 15 feet. It's anchored out there. This is another, sorry about the quality of these, it's just from the internet. That's what it looks like on the left, kind of. That's how it's anchored, one anchor line from each corner. You can see on the bottom there that these anchor lines, I mean, they go from each corner quite a distance down. I'm gonna move right along. This is what it would look like. It looks like Navarro Head almost, doesn't it? Navarro Beach. There'd be 4 or 5 of these things. I mean, whatever there are, 6 big structures, incidentally, which are lit at night by requirement for the U.S. Coast Guard. They'd be very well lit to avoid a navigational hazard. Say goodbye to your expensive beachfront property. You'll be looking at a city. This is Energy Tech. That's their version. If you look closely up on the right here, that's 60 meters. And that's 35 meters. So this thing is big, very big. This is Energy Tech. PG&E has not revealed which company or what they're going to put out there. This is what you might see. That's what it looks like, the superstructure from their own website. Not a pretty sight. And I need to say right here and now that I am not an environmentalist. When you've killed as many fish and sea urchins as I have on the ocean, you do not get an Earth First membership card. This is another movie. Unfortunately, it's not playing because I was unhooked by PG&E. This is what this was going to show is a wave dragon. It's called a thing in Scotland that I'm just going to move right along. Like I said, I had some moving images here. This is what it looks like when the waves go up a funnel into a reservoir, a floating reservoir. The power is produced by the water coming down through generators. Now this is the granddaddy. This is the Palamas. It's huge. If you can see those vessels next to it, this thing is, it's called, Palamas is Latin for sea snake, and it does look like a snake. It's huge. That's the size of it. If you look here, these are people. That's a human, this thing is as big as a BART train. And it's heavy. And they're talking about putting arrays of these things covering a square kilometer. That's what a 40 megawatt installation would entail, a square kilometer of these things. And you can imagine if I can't, it's hard to describe to you the scale and size of the thing, but if one of these started breaking up and hitting any others in a storm, you would have a major disaster. This is how they're going to anchor them up. As you can see here, each one is approximately 150 meters, so look, close to 2 football fields long. Not quite, but that's pretty long, 2 football fields for one of those guys. And this is how I've never seen this type of anchoring setup that they're talking about here, with a float and a sinker to keep it in place. I've never, I'm a United States Coast Guard sea captain, and I've never seen anything like that. Now this is the underwater arrays that the PG&E was just talking about.